Continuing our discussion in section 6.1, now we're going to look at some of the operations you can perform on vectors, including things like adding two vectors together or multiplying them by what we will call a scalar number. So here we're defining that you have two vectors. There's a vector being labeled as u that has a horizontal and a vertical component, and there's a vector called v that has another horizontal and vertical component. So to add two vectors together, it's actually as simple as just adding the horizontal and the vertical pieces together separately, and then you can keep it in component form that way. Now later on, we'll also look at how to add vectors graphically, but for starting off right now, I just wanted you to be able to see what it looks like, and then we'll get to the operations of doing it in the next section. So what I really wanted to emphasize here is that the order that you add the two vectors in does not matter. We've talked about how if you have two numbers, like 2 plus 3, it's the same as if you write 3 plus 2, and the same is also true for vectors. So graphically, what you're doing is you're lining up the vectors head to tail. So where one of the vectors ends, the next vector begins, and then once you have combined all the vectors together, that ending point is the combined vector of u plus v. And what I wanted you to see was that you could have flipped the order. You could have done vector v first, which had the longer horizontal component and a very short height to go, and then added u from there, and you would have ended up at the exact same point. So just like with normal addition, vector addition, the order does not matter. But for now, all you really need to focus on is adding the x components and the y components separately. So here's a quick example. We have vector u, we have vector v. They want us to add the two of these. So I'm just going to take the horizontal piece, -1 plus 4. And then for the vertical piece, we'll have 3 plus 7. Which means if you combine both of these vectors working together, you will get 3, 10. One way to interpret vectors, we'll look at applications later, is you could think of it as a force acting in a certain direction, and then this would be a second force acting in a different direction. So now we can find what effect the two forces have when you combine them together. Like if you have two people trying to move some heavy furniture, this would be the vector that describes how far it's going to move horizontally and vertically based on these two individual forces. Scalar multiplication is when you take a single vector, like u1, u2 here, the horizontal and vertical pieces, and you multiply the vector by a constant out front. So that number that we're multiplying out front is what we call a scalar. So if you ever hear me say scalar multiplication, it just means multiplying a vector through by a single number like 3. To graphically show you what happens with scalar multiplication, let's pretend your vector u looks like this for a second. Then if you multiplied by the scalar 2, as in you doubled the vector, you just distribute it through both the horizontal and the vertical pieces. It's going to double both of those separately, and then that means it's going to be going in the exact same direction. It has the same slope, essentially, but it's going to be twice as long. If that scalar had been a number like 1/2, again, you would distribute that through the vertical and the horizontal pieces, and the 1/2 means it has the same slope, but it's half the length. So if we found the magnitude of these, it should be exactly 1/2, and the other one would be exactly twice as long. And the last thing I want to emphasize is what happens if you have a negative in front of it. The negative value is going to keep what looks like the same slope, but it's flipping the head to tail on the vector, so it would actually be going in the opposite direction. So if it used to go right 1, up 3, now it would be going left 1, down 3. It's going to flip both of those directions. Now the fact that this is a -2 means it flipped the direction and it doubled the length so that it looks like the 2u vector in magnitude. But scalar multiplication, just think of it like distributing through any other set of parentheses. You need to take the number out front and multiply it by each piece of the vector. So here we're given a vector u and a vector v, but notice that the question is actually only asking us to perform an operation on vector u. So vector v is not going to be useful for us in this part of the question. So be careful about which vectors they use and what multiples or operations they have indicated. So for this example, we're just going to take the scalar of 3 and distribute that through our vector -1, 3. So if you multiply both of those values by 3, you'll have 3 times -1 and 3 times +3, which is going to give me a vector of -3, 9. And so if we found the magnitude of the original one and then found the magnitude of this one, they would be exactly 3 times as long. but they didn't ask us to do that in the directions, so we're fine stopping right there. It's essentially the same as taking vector u and applying it 3 times. So if I did u plus u plus u, which would equal 3u, you would see that you end up going left 3 and up 9. Here's one more slightly more complicated example where this time we're going to be using both the vectors u and vector v, and we're going to multiply the first vector by 2, and then we're going to take the second vector and we're going to flip the direction on it because the scalar has that negative in front. So instead of going right and up, it's going to go left and down. So just distribute through the 2 vectors. For the first vector, if we multiply everything by 2, I will have negative 2 comma 6. And then it's asking us to add that to the second vector, but we're distributing a negative 1 through it. So this will end up being negative 4 comma negative 7. And now that I've done the scalar multiplication parts, now we can go ahead and do the adding operation here. So negative 2 plus negative 4 and 6 plus negative 7. So this expression that we have written 2u plus negative 1v ends up with a vector going left 6 and down 1 is what we've defined. And that's all for the notes. Thank you guys.